So I'm trying to set up a chronometer here. Okay. Hi, everyone. I'm Gabriella Barros. I'm a PhD student at the New York University. And I work with generating game content using information that's freely available online or open data. And I'm going to talk a little bit about that here. But you may ask, why do something like that? Sounds like a hassle, like something that is way too much work for what's worth. We have, right now, a massive amount of information online. We generate information by the minute, and we don't really use all of what we create. Sure, we go to Wikipedia and we read a couple of articles, we see stuff on our feed on Facebook, we see stuff on YouTube, but that information could be used for so much more and serve as input for so much content generation that we can automatize in a way. And it has been done, the use of... Is it alive?
Yeah, it should be fine.
Sorry, everyone, I dropped the microphone thingy. I'll put it in my pocket. So the use of information, like from the real world into games, has been done before. Maybe the biggest example is Pokemon Go, where you can walk around in your city and catch Pokemon. And some places which are supposed to be interesting become Pokestops, and you can catch items and so on. But the information about the places that are interesting and so on is not really automatized. It's basically something that they had users suggest when they did a former game called Ingress, and they just reused this for Pokemon. So when I talk about using real information, it would be interesting if we could do that in an automatic manner. So one example is this game on the left, right, depending on how you look, right? It's called bar chart ball, and basically you have this bar chart with places on the UK and a ball over this chart. And on top of it, you have a bunch of attributes like rate of unemployment or amount of people that were born in a certain year and so on. So you can select different attributes, and the chart will morph to that attribute that you selected, and the objective is to move the ball around so you can take it off the chart. So that's an example. The second one is an example of what a data game is. Data games are games that use real-world information to procedurally generate content. So basically, you have any source of data, Facebook, Twitter, government information, and so on. You have a way to crawl that information to get it, to acquire it, and you have a way to transform that into a game content, whatever content that is. If it is a character, if it's a dialogue, if it is a patch of grass. And a game that follows these steps can be considered a data game. In that sense, Pokemon Go can't because it's not automatized. But then you can ask, why? Again, we have so much data, but I still don't want to use it. Well, players usually identify with what they know. If you go on Steam Workshop and you go on Civilization 5 and you search for a world map, you're going to find dozens of maps that were made by users of the game, by players, because they wanted to play on a representation of Earth. And you can find that in all sorts of games. People putting Barack Obama on Civilization, or most recently, and maybe a bit tragic, I think you guys know about the GTA 5 mod, where they added the Samsung 7, and if you throw it, it explodes in the game. And that's a way of players inputting what they see in the real world into the game. Additionally, it's not uncommon for a game designer to take inspiration on what he lived and what he's seen, whether this is a real experience, something that he's done throughout his life, or a book he read or a game he played, and input it in his creative process. So if a designer does that, and we want algorithms that in a way behave somewhat like a real designer, then why can't the algorithm do the same and get inspired by our own world? So yeah, okay, now you might say, sure, there's a reason for this. Maybe. But what can you actually do with it? What kind of games can you do? So I'm going to talk a little bit about some projects that we've been working on. Some of them are ridiculous, and I warn you now. Some of them I'm very fond of. Most of them I'm very fond of, maybe all. So I'm going to start with the biggest one, just called Data Adventures / Wiki Mystery. So the idea of this game, if the video ever plays, is to walk around through Wikipedia, but in a adventure point-and-click sort of way. So everything that you see in this game has been crawled out of either Wikipedia or OpenStreetMaps or Wikimedia Commons. So basically, in Data Adventures, you have the goal of, from one article about a person, reach out the other article. And then you follow a single path that leads you through different locations and talk to different characters and see different items and so on until you find the last person. And in a way, it's very straightforward. But by no means it was an easy task. And I was pretty sure I had sped it up. So basically, you follow this path throughout and talking to people and going to places and seeing information, all of it scrapped from the real-life information, until you find, in this case, Vladimir Putin. Yeah. Not my favorite version. Like, there is one where someone inputted Godzilla and Scooby-Doo, and it's gorgeous. And then we have Wiki Mysteries, where basically you have the same idea. You have to crawl Wikipedia, but now you're a detective, and someone inputted a person, let's say Justin Bieber. So the algorithm goes and kills him. Justin Bieber is dead. And you have to figure out who did it. So the algorithm finds people that are connected to him and takes them as suspects and creates a plot around them with places and locations related to them. So you have to find them in the map and then figure out through clues who did it and why the other people couldn't have done it. So what are their alibis? And I thought I had recorded the ending, but basically I stopped for some reason and I lost. I got the wrong people. This one is way harder than the previous one. So this is an example of a couple of examples of what you can do with data, but how can we actually create this? So I use 3 main sources of information. We use topological data, so maps. We use Wikipedia articles, and we use images from Wikimedia Commons. All of those are acquired through a crawler, and they pass through different steps of either artificial intelligence or generative methods of dialogue creation and so on to spill out places and NPCs and items and so forth. So I'm going to talk a little bit about how do we generate each part of this, just in very fast manner. So let's say you want a game where you start with Donald Trump and you go to Tony Blair. And we need a plot for this game because it's an adventure game, and adventure games are known for being heavily relying on stories. So one way to see this plot is as a series of links that lead you from one Wikipedia article to another. Once you have a series of links, you can transform each one of them into a respective object. So if you have an article about a place, create a place in the game. If you have an article about a person, create a person. If you have an article about something abstract, like mathematicians in the 20th century, create a book that talks about it, or a photograph or something like that. But how do you actually get the information from Wikipedia? We use something called DBpedia, which is basically Wikipedia but structured. So everything in DBpedia is in the form of a resource, a property, and a value. So a resource could be Alan Turing, a property could be residence, a value could be Winslow, or date of birth, and so on. And you can acquire this information to this link, where they have a Sparkle endpoint. Sparkle is similar to a SQL language. So basically, you ask for, you make a query where you, for instance, select everything that has one connection to Alan Turing. And then it returns everything in the form of a table. So basically, we generate a plot by making multiple queries that lead you from one person to the other. So give me anything that is within this path, anything that leads from this guy to the other. Additionally, we need to get the maps too, so you can walk around. For that, we use OpenStreetMaps, which is basically open source version of, well, maps in general. And there is this very cool software called JMap Viewer, which basically takes care of all the rendering of the images. So we only need to input a place, geological coordinate, and it spills out a map, and you can use it in the game. But data is not always reliable, and sometimes it comes up with these weird things, either because the parser is not perfect, because it cannot take every tiny case, or because the actual information is wrong. So in this case, for instance, it just generate the city of Oregon, the state of Oregon, in the middle of the ocean. And you actually could go there and talk to people and so on, but it was in the middle of the ocean. Or you can go to the house of Lord Voldemort and talk to him, and he's a bus with the face of Voldemort. And we find some really funny stuff, like saints that are represented as pigeons, and pieces of dialogue that have no information because there is no information in English. So it tries to get something from another language, and it can't. And a part of working with data is to accept that not everything is going to be perfect, and you're going to have to deal with some absurdity, and that's perfectly fine. But then, well, this is a talk for a game jam, and you might be, okay, this is too big. This is absurd. I want something simpler. And well, what if you use the same, bear with me for a moment, what if you use the same information that you have here, but you create a simpler game? So in this game, you have to walk from one place to another and explore that path. What if instead of walking, you have to date people? So imagine if Tinder and Wikipedia had a baby. And we are making this project right now. It's called Tinder Wiki or Wikidate. We are still on the fence about it. But the idea is you start with a person. You are this person. And you have to swipe left and right to date people. If you get a match, it's because you're in the right path towards your end goal. And then you go on a date with that person. And you can answer questions like, take him to dates in the right direction, and try to figure out if he was born in a certain date and so on. And finally, if you do everything properly and you follow the right path, you're going to get the final date with whoever you're looking for. In this case, it's Nikola Tesla. So it is a simpler game in a way, but it uses the exact same information that the other one does. And we could even make it simpler. So let's say you're using Wikipedia, but you don't want to go through the Wikipedia and deal with all that complication. So you just want to get the HTML information of a page. Well, you could generate, let's say, Hearthstone team deck cards, which is what we do here. So we get a list of things from Wikipedia. So Spanish provinces by population, and it tries to, based on real decks, classic decks, map the things on that list into the cards. So we can create a card about Spain where it's a minion and its attack is 12 and so on and so forth. And this is a very simple transformation from data to a game content to an item. But it's not less fun or less entertaining because of that. And what I'm trying to say by showing this is that you can have different ways of acquiring and of using the same source with a little bit of creativity. I love H.P. Lovecraft in this one, by the way. So when we talk about data, we tend to think about real information in the sense of, okay, I have a map, I have historical data, I have information that is real, but anything that you can find tangible in the world can be considered real. So you can consider television as a source of input, or YouTube, or books or even games. And game designers do take inspiration from them. So how come the algorithm couldn't? So let's say we want to use a weird sort of data. Let's say that we want to use scientific papers. And we want to make music. And this is a project we did last year. Basically, you can just input any sort of paper, like especially academic papers, but any sort of paper. And it spills out a song with lyrics and a melody. And you can actually sing the song. It might not make much sense because we use a very simple strategy to generate the songs. But we thought it was a fun application. And if you want to use it, that's the link. And it's available online. But basically, our strategy was, we get the paper, we use word count to verify how many, the types of the words and how many times they appear. And then we get templates from real songs. So let's say you get a pop song, and it goes in a form of a noun, verb, object, verb, object. And you filled it out with words from the paper. And this is, in many ways, very simplistic. So let's say we want to use something bigger. Why not generate fanfics about books? Fanfics of books. And if we want to, can't we generate fanfics that use other sorts of data to add something different and some novelty to the fanfic? So let's imagine for a moment that we're trying to do fanfics about a genre. And we want something different. So why not use dinosaur erotica? And I'm not even joking. This is a genre on Amazon. There are tons of books on this. So basically, we we input tons of books into a machine learning algorithm, and it spills out fanfics about that. And then you can use some sorts of bits and pieces from Wikipedia or from Twitter and add some flavor to it. I'm sorry. I love this work. This is amazing. I just love it. And what I'm actually trying to say with this is using data is fun, and it's weird, and it's going to come up with random stuff. But if you can, you should try it. Even if it's just for fun. Generate something absurd. Generate clouds using election polls or motivational phrases from demographic indicators. Generate something that anyone else might think that it's silly, but that's going to end up awesome because it just has to. It doesn't have a way of not being great in its absurdity. And and that's it. So embrace data and embrace what comes from it and all the insanity that comes from it, and have a lot of fun. Thanks.
So as usual, we have some time for questions. By the way, if you come in and you can't see, feel free to sort of scooch around to the space here or there if you want to move your chairs. Any questions? There might be some questions on the stream as well. So.
Hi.
I think this idea of embracing absurdity to deal with when algorithms don't run perfectly is a really interesting idea. Do you think of other places that can be applied besides games? Does that work in other spaces?
I guess it depends on how tight the final object has to be. So if you're talking about a literary book, you're trying to actually generate a book, it can't be as absurd as a fanfic. And it can't be as absurd as a Tumblr post, for instance. So I guess it's about taking the context of what you want to generate and see how far you can take it. Hey.
Do you have any advice? So, a lot of people will be watching this and they'll be excited to try out things like DVpedia and things like that. is it, what's the easiest way to get started? Is DBpedia the best thing for them to get into, or?
If you are used to crawling web pages, then just getting the information from the Wikipedia might be easier. The point of DBpedia is that it's structured. So you get things as if you were getting from an original, like a real database. And it might be a lot easier to parse. So for instance, we have to parse characters for Wikipedia, for Wikimystery. So we have to get their names and where they come from and the location of where they come from. And crawling that from Wikipedia might be harsh because you have a lot of noise from the text. But from DBpedia, all you have to do is get the property and you have the information. Yes?
Just another question about the absurdity aspect. It kind of seems like if there are no cases where absurdity doesn't inevitably happen, does it always kind of have to gravitate towards more of a comedic approach with this kind of thing?
No. If you're using, for instance, let's say you're using government data, so you have a government spreadsheet, you know that that information will never go far from that. So you have a very controlled space to travel through, and you can't predict very well how absurd it's going to be. So in the end, you're going to end up with no absurdity at all. But when you deal with information that has many different types of input or templates, so for instance, for the Hearthstone, we crawl via Wikipedia and crawl lists, but not all the lists have the same format. So we either make a crawler for each possible list, or we accept that sometimes it's going to get a link wrong, or it might just ignore something that it could have used. And basically, it's again about the context of what you're generating. How controlled is the environment that you're using?
We also have a question from the stream, which is, I've lost it, sorry. What was the best fan fiction title generated by your program?
Right now we're actually training the net, so we haven't generated anything yet. But if you do, if you want to follow us on Twitter, we're probably gonna tweet some stuff as soon as it gets done.
Which account should they follow? Should they follow you? Or?
Yes.
Okay, yeah, okay. I've tweeted that out as well. All right. Any more questions?
Yes?
Have you had any issues in terms of recording the internet, in terms of like copyright infringement or like picking up data that's...
So far not. Even with Hearthstone, we don't really make like actual Hearthstone cards, so it's not meant to be played with apart from a controlled environment, so in your machine and with a friend, for instance. But for stuff like Wikidata and data adventures, Wikimysteries and data adventures, we try to only use information that's actually freely available, so Wikipedia by itself, or that has a free license. So Wikimedia, everything in theory that is there is supposed to be to have a license for reuse, and we basically use those.
All right. Let's thank Gabriella. Thank you very much.
Thank you.